Good morning. Sorry that I am not here with you. This one was not really a planned one. Sorry that I'm not with you. I will be back on Wednesday with you, and when we come back, we should be able to finish some things out and then move on to a test. So be prepared for a test at the end of this week. So I'm going to jump back into your homework that you had on Friday, the combining functions. And then we're going to do a lesson that involves some calculator, our ability to kind of look at, some values for a given function and then compare those functions. So anyways, we'll jump into that a second, but let me go through your homework from Friday night, and I'm just going to go through the whole thing just to make sure we were all on the same page. I think I had in every class a quick description on what you do with numbers 1 and 2. The fact that you're stopping and you're trying to avoid this accident, there's two things that we had to consider. One was the driver's reaction time, right? That's important, which they give me as an equation, r of x, 3/4 x. And then also the braking distance, which is the equation b of x equals 1 over 15 x squared. So if you just think logically, in order for me to stop, in order to avoid this accident, two things have to happen. Both of these things have to be taken into consideration. So when they asked me to write the equation for t, and I would probably do t of x, since the equation itself has x's in it, I have to keep both of these two things in mind. The braking distance, which is 1 over 15 x squared, and then also, so plus, I have to take the reaction time into consideration. So those two things, in order for me to write this equation, I need to add them. So if you struggle with that one, that was the deal. Now the second question, if you know this equation, should be really simple. They want to know, well, what is that total stopping distance if a car is traveling at 60 miles per hour? So all I'm going to do here is I'm going to plug 60 into x. So I'm going to do t of 60. And this requires me just going to my calculator and typing all this in, because there would be no expectation that you could do this in your head. So I'm going to do 1 over 15, open parentheses, 60 squared plus 3 over 4 times 60. So I'm going to go type this in, just so you can see. I'm going to use alpha y equals number 1. That is 1 over 15, and then times 60, close parentheses, squared, plus alpha y equals number 1, 3 over 4 times 60. And it's going to do all the work for me, and it's going to tell me that it looks like it would take me 285. And how do I answer this? Well, if you look at these, it says the distance is in feet. So that's going to be 285 feet. Okay? So that was the one that was different. The next two questions, 3 through 5 and 6 through 8, those were almost identical to what we had done in the previous problems. So first of all, if you read this problem, it tells me the fixed cost, let's look at it together. The fixed cost to run my business is $300 per month, and the cost to produce each of the hats is $12. And then it says, different concept here, the hats will sell for $29.95. So first of all, let's start with that red. The red is the cost. That's the cost of this business that he's running here. Now yesterday or Friday we talked about a different example, but the two different fees that I have to consider when I'm doing cost is fixed cost, which is a value all on its own, what we call a constant, and in this case that was $300 a month. Okay? Plus we have what we call a variable cost, and that is every one of these hats have to cost a certain amount to even make. Okay? Whether it's the machine or it's the material, whatever it is, it's $12 per hat. And I'm going to call those hats X, because we don't know exactly how many we made, but we know we made X. So to produce these hats this month, I am going to have to pay $300 plus $12 for every hat. Now, number four is the revenue, right? That's how much money I bring in when I sell a hat. So it tells me the hats will sell for $29.95 per hat. So $29.95 times X is going to be how I accumulate revenue. Now, just like the problem that we did for homework, to find the profit, we have to do the revenue minus the cost. So when we talked about subtracting the other day, we said, hey, the thing you got to remember is when I subtract this C of X, all those signs have to what? They all have to change. So we're going to have to change those signs of our C of X equation. So here's what I do. Okay, over here, I'm going to take my profit, and I'm going to find this profit by taking my revenue, $29.95, for every X that I sold, and I'm going to subtract this entire equation. So what's that mean? Well, that means that positive 300 is going to come down as a minus 300. And positive 12x is going to come down as minus 12x. Now, when I accumulate these, when I take R of x and I subtract C of x, see those signs changed, I'm going to have my formula that represents how I can accumulate profit. So 29.95 minus 12 is 17.95x, and then of course minus 300 drops down. And there you have it. That's my equation for profit for this particular company. Now let's go down to the last one. And we have two different things. And over here on the right, we actually need to do something before we answer these questions. In our other equation, we did it below it. So I'm going to do that here as well. We need to come up with what is C of x and what is D of x. So C of x is, if you notice here, it represents the coupon. All right. So when I'm dealing with a coupon, and this is very similar to yesterday's or Friday's assignment, it tells me that Wally World texts me a $10 coupon. So here's the deal. Whatever I purchase at Wally World, whatever the entry is that comes in, when I take the cost of that, okay, which we're just going to call X, when I take the cost of it, and it has to be whatever it is, it says a $50 purchase, which really doesn't have anything to do with this until the very end. We are going to subtract. Think about it. If it was a $50 purchase, what would I do with that coupon? Well, I would just subtract $10 from it. So it's just whatever your cost is minus 10. That's how you deal with your coupon discount, which is just like the homework that we did. But when we deal with the discount, it's a little bit different. You see, instead of paying 100% of X, it's saying that I'm going to get 15% off. So that means I'm going to take the full cost of X and I'm going to subtract 15% of X off of that. Now, if I took this and simplified it, like we did the homework, if you recall, we had the same thing. It was 100% of X minus 10%. So they moved that decimal 2 to the left and it was 0.1x. Well, we're doing the same thing here except it's 15% of X. So 1x minus 0.15x is 0.85x. And I hope this makes sense. If not, let me explain it real quickly. If I get 15% off the cost, I don't pay 100% of it. If I get 15% off of 100%, I'm only paying 85% of the cost of that item. So there are my two equations. And number 6, we want to do C of D of X. Now, what does that mean, C of D of X? It means that we're going to go to C of X and we're going to plug D of X, which is 0.85x. We're going to plug it into there. So instead of this being X minus 10, we're going to replace this X right here with 0.85x. So instead of X minus 10 this equation will be 0.85 x minus 10. Now, that's the equation. Now, what does this mean? Well, it means I get to take 15% off. See, whatever I purchase right here at x, the first thing I do is multiply it by 0.85. That means I get to take 15% off and then subtract the $10 coupon. That's the order going when we do C of D of x. Now let's see the next one. The next one wants me to do D of C of x. And C of x is 0.85, I'm sorry, wrong one, is x minus 10. C of x is x minus 10. So now I'm going to go down here to this equation, and when I see C, or x right here, I'm going to replace that with x minus 10. So instead of doing 0.85 times x, I'm going to do 0.85 times x minus 10. Now, I want you to notice, I could simplify that, and it might be helpful to you if you did, but just looking at it the way it's written compared to looking at this one the way it's written, if I purchase something, whatever that purchase is, x, if I purchase something, what would happen first? Well, as you see here, you would subtract the $10 coupon first. So this one subtracts the $10 coupon, and then takes the 15% off. See that? Oops, wrong thing. 15% off. See how it's it's subtracting 10 first? So it's taking the $10 coupon off, and then you pay 85%. So you take your 15% off after that. So here we were taking the 85% off first, and then subtracting 10. Here we're subtracting 10 first, and then we're taking off 15%. So how do I know which one's better? Well, I'm going to do the two, okay? C of D of x, when they want me to use a $50 purchase. So I'm going to do C of D of 50. So I'm going to go back up here to what C of D of 50 is, and I'm going to type in 50 into that spot. So I'm going to do 0.85 times 50 minus 10. Okay? 0.85 times 50 minus 10. And my answer is $32.50. That's how much I'm going to have to pay. Now let's do the other one. Now let's do D of C of 50. So I'm going to go back to this equation here, and I'm going to, oops, I need to go back here. I'm going to go back to this equation that I've circled, and I'm going to do D of C of 50. I'm going to plug 50 into that equation. So it's going to say 0.85, open parenthesis, 50 minus 10. So let's go type that in just like I see it. 0.85, open parenthesis, 50 minus 10. So if I do the $10 coupon first and then take 15% off, I'm paying $34 instead. So let's go back to our paper. Which one's better? Would I rather pay $32.50 or would I rather pay $34? Well, that's a no-brainer. I definitely would rather pay $32.50. I save $1.50. Now, I know that that's not like a crazy amount of money, but it's something. And something is better than nothing. So I'm going to elect then to take the 15% off and then subtract the $10 coupon. Okay? All right, now, at this time, if it's not been done already, I'm going to ask you guys at this point for the substitute to hand out the note sheet if it hasn't already been done. And we're going to move into a different lesson. We're going to move into comparing functions. Okay, you definitely need to get your calculator out. And I would always encourage you to do what I just did and reset that calculator. Okay? So today we're actually talking about comparing properties of two functions. So In the last couple of weeks, when we've looked at equations, we've looked at some what we call important points. We have looked at things like the x-intercepts. We've looked at the maxes and the mins. We've looked at the y-intercepts, and we've talked about those different things as far as just the functions go. But now what we're doing is we're moving to a different line of thinking, and that line of thinking is, well, when I have an actual situation, whether it's a graph or whether it's an equation or whether it's a table, could I compare the various things that I see on that particular mapping? Whether it's a graph or whether it's a table, do I understand those two things enough that I could compare the two functions and make decisions based on it? So here's the point. We have a couple of equations that are kind of staples, like they always represent certain things. For example, when something is being launched, there is an equation that we can follow, and you can see it here. Okay, I'm not asking you to memorize this. You're not going to be tested on your ability to remember these formulas. The thing that we have to focus on is this. What do these things represent? So, for example, h of t. Now, remember, that's in the f of x spot, right? F of x we know means y. So what does y, or where a graph crosses my y-axis, okay? My y-axis, what does that tell me in real life? If I had a real life situation, what does something going through the y-axis mean? Well, it means that's the height of the object t seconds after it's launched. Okay, it's the height of the object after it's launched. Okay, so the y-axis, specifically where we see the y-axis, where the graph is coming out of the y-axis, that's going to tell me the height of it right as it's getting launched. And then as it's flying through the air, we can see various things as it moves. Now, v sub o, as you can see here, represents the initial velocity of the launch, and h sub o represents the initial height of the object at the time of the launch, which we'll talk about in just a second. So let's look at an actual example, and then we'll be able to go from here. Based on the equation, now remember, you got to go with this one if you're doing feet, this one if you're dealing with meters. Player 1, the ball leaves player 1's hand at a height of 7.8 with an upper velocity of 15.5 feet per second. So 7.8 feet, that is obviously going to be the height that it's launched, right? Which one is the height of the launch? That is the initial height of the object at the time of launch. That's h sub o. This is the velocity, 15.5. So here's this equation, guys. It's h of t equals negative 16t squared is a constant. I know it's not a constant from the sense of it's got no variable. It's a constant in that part of the formula does not change at all. Plus v sub o, that's your velocity. It's 15.5 t plus h sub o, that's the initial height of it as it's getting launched. And it's getting launched at a height of 7.8 feet. So there you go. There's my equation. Now, I want to first take some time to go graph this equation and just learn a couple things about it, okay? Let's go to y equals, and let's type this thing in. Now, obviously, in lieu of t, I'm going to use x. So it's negative 16 x squared plus 15.5 x plus 7.8. I'm going to graph it, and you don't really see a whole lot here in the graph. I mean, you can see looks like it's crossing the y-axis somewhere in here. We should know what that is, because what was the initial height that it was launched? 1, 2, 3, 4, 5, 6, 7.8. Now again, I didn't just count that because I I can see it. I can't see that any better than you can. But I remember that in my equation, the initial launch height was 7.8. 7.8, the initial launch height. That's where it crosses the y-axis. So the height that something is launched, what's the x value? Left, right? I don't go anywhere. I go 0 left and right. So my x is 0, my y is 7.8. Let me show you this in the table. Go to second table, and here we see at 0x, the y-axis, it's crossing at 7.8. Now, real quick, let's go to the other example. So 0, 7.8 would be comparable to this player 2 shot being at 0, 7.2. So what do I know based on that? Well, look, the initial launch height for player 1 was higher than the initial launch height for player 2. You see that? 7.2 compared to 7.8. It's the place where x is 0. X is 0. So that's one thing I can tell. Also, look at this graph. What else is important in the graph? Well, how high it goes. How high. Now, I can't see that height. I could zoom out if I want, but I'm not even going to worry about it. I'm going to do second trace, and I'm going to find the 4, the maximum. Now, you see the cursor blinking right here? Since that's the last place I can really see it on the left side, and I know it's going up but coming back down, I'm going to go ahead and push enter on the left. And then I'm going to scroll until it comes back down. See it? It just popped in and push enter again. Push enter one more time, and it looks like it finds the maximum height at about 0.48 on the X and 11.55 on the Y. So that's going to be the maximum height that shot gets. The last thing that's really important is how long did it take it to land? Remember, that's your x-intercept. So let's go see what that x-intercept is. So let's go second trace again, and let's look at number 2, the 0. So I'm going to scroll on down, and look, there's left bound because it's just before I cross, push enter. Then go on cross, push enter again, push enter one more time. It looks like it's crossing the x-axis at 1.33. 1.33 is where y equals 0. So I know some things now about player 1's graph based on graphing it and looking at the table and also finding those maxes and those x-intercepts like we talked about in previous assignments. Remember what that was? Where did it hit the ground? It was 1.33. Okay, so let's go answer some questions. Which player shot at the higher initial height? Well, we just discussed that. Remember, player 1 shot it at 7.8 feet. Player 2 shot it at 7.2 feet. So this is definitely going to player 1. Now let's see some other things it asks about. B says, which player's basketball reached a higher maximum height? Now remember when we did it here a second ago, when we did second trace and I did the maximum? We probably should have looked at those questions they were asking a little bit earlier. When I did enter on the left and I did enter on the right, remember what that maximum height was? That maximum height was 11.55. So player 1 had a maximum height at 11, so max height was 11.55. Now, how do I compare that when I can't see the graph? Well, look at your numbers, guys. Look how high this one got. At one point, this one got to 17.325. Now, could it have potentially got even higher than that? Absolutely. But it at least got to 17.325. That's much higher than the 11.55. So when we compare those two numbers, it's clear that player 2's got much higher. Now let's look at the next thing it asks. If both players shot air balls, which player's basketball hit the floor first? Remember when we did this one and it was just barely past one? That's when it hit the ground. It literally took 1 point something seconds. I don't know if you guys remember it. Let me do it real quick because it doesn't take that long. Second trace 0. I just need to scroll just shy of it, enter, just past it, enter. This one hit the ground after 1.33 seconds. 1.33 seconds, okay? Let's see, hit ground in 1.33 seconds. Now, look over here. This thing went up in the air, went real high. At 1.33 seconds, had it come back down to the ground yet? Well, no, look, it's on its way down now. It still hasn't crossed into negatives. And because it hasn't crossed into negatives, we know that it still hasn't hit the ground after at least 1.75 seconds. Well, 1.75 is definitely longer than 1.33. So who's actually hit the ground first? Well, 1.33. 1.33 came faster. So player 1 again. And then the last one, which player had a greater average rate of change between 0.25 and 1.25? Okay, rate of change. Let's talk about this real quick. Rate of change is taking y2 minus y1 and dividing it by x2 minus x1. Okay? Rate of change is slope, essentially. And it's telling me where I want to find slope from and to. From 0.25 to 1.25. So first and foremost, I need to find what those values are at 0.25 and at 1.25. So let's go back to our graph to look at player 1. If I went to the table, you see I can't see 0.25 and 1.25. So I'm going to show you a really helpful tool so you can see those odd type numbers on your table. You see this bottom thing on yours where it says press plus for change of table. That's what that means. So I'm going to do that, and I'm going to change my table. Instead of every 1, I want to do every 0.25. And look at what it does to my table. It changes it to every 0.25 increment. So if I go back to my paper real quick, it says they want me to check the rate of change from 0.25 to 1.25. So let's do player 1. Player 1. And I'm going to do 2 order pairs, y'all. I'm going to do one with the x value of 0.25. And I'm going to do one at the value 1.25. So I'm going to go back to my table, and sure enough, look at this. At 0.25, it was 10 point, and we'll just round, no, we don't have to round here, 10.675. And then player 1 at 1.25 was 2.175. Okay? Now, I've written those down. I want to come back to my paper because we also want to do the same thing for player 2. But the beauty is for player 2, we already have these values. Look, at 0.25, it's 12.75. Let's see, what was it again? 12.575. And then at 1.25, we just have to look at the table they've given us. It's 14.075. So we are going to use this equation in order to find which one has a greater average rate of change. So we're looking for the bigger value here. So let's set it up. If I call this my first x and y, and I call this my second x and y, I plug it directly into this equation. Here's what I get. 2.175 minus 10.675. That's y2 minus y1 over x2, 1.25, minus x1, 0.25. So I just push equals here. Let's go do it. Let's go second, quit, get out of here. I'm going to do alpha y equals number 1. And I'm going to do 2.175 minus 10.675 and I'm dividing that by 1.25 minus 0.25. And that is a negative 8.5 change. Okay, so let's go write that. That's a negative 8.5 for player 1. That's how much it's changing. Now let's go look at player 2, and let's do the same thing. We're going to name this our first x and y. We're going to name this our second x and y. That's how it works. So when I plug it in, I got y2. Look at the equation over there. It's 14.075 minus y1, which is 12.575, over x2, 1.25, minus x1, which is 0.25. So let's go plug this one in too, okay? I'm going to grab my alpha y equals number 1 fraction bar. I'm going to type in 14.075 minus 12.575, and that is over 1.25 minus 0.25. And my answer is 1.5. So let's go back to the paper. The question asks, well, hey, which one has a greater average rate of change? Now, when I see greater, I mean, that means bigger. So bigger, if you're comparing positives to negatives, well, there's a no-brainer, okay? The one that's greater is the one that's bigger. So that's going to be player 2. Player 2 has a greater average rate of change because it was positive, where the other one was not. It was negative. So we compared the functions. One of them, we had to graph it, and we had to look at key points. The other one, we had to try to figure out the key points based on the table. So you're going to kind of do the same thing with tonight's homework. You have a graph of f of x. G of x, they give you an equation to go graph. And then h of x, they give you a table that you're going to look at. You're going to be able to answer all of these questions using the graph that's already drawn, the graph that you will go draw on your calculator, or this table to answer all of these questions. And then you've got one more, number 2, and those are your assignments for tonight. Okay, you got about 10 minutes or so. So go ahead and try this out. Use your calculator for this one. Use your calculator for this one after you write your equation. And then hopefully you'll have this all completed by tomorrow. Or no, not tomorrow. No school for you guys tomorrow. So on Wednesday. All right, I hope you guys have a great day.